Yeah? Awesome. Great. Sorry about the technical glitch. We're dealing with a very historical projector system here. So as Anna introduced, my name is Yashi. I'm a new professor here in the Comp Sci program. My appointment is actually joining with the computer science department. That's my home department, but I'm also jointly appointed with the cognitive science program. So Hannah has given you a very broad overview of what cognitive science is. I thought what might be interesting is to zoom in to a very small topic. In fact, a small research project that I did with one of the students here, Samin Khan, over the past semester. So if you're interested in this project, definitely talk to Samin. He's the expert. So the project is about predicting brand name gender. So if I give you a brand like Nike, can you tell whether it's female or male just from the name? Okay, that sounds pretty bizarre. Is there a gender to begin with, right? So and the specific way I'm going to approach that problem is through this phenomenon known as sound symbolism, the fact that names convey some sort of information about your gender. And I thought it's an appropriate topic to discuss here because it's a good mixture of cognitive science, psychology, linguistics, but also computer science. So it gives you, even though that's a very small project, it gives you a broad overview of the methodologies that we can potentially take in Cog Sci. I want this to be a very interactive session, so if you have any questions or suggestions, feel free to just raise your hand. Before I begin, I want to get a good notion of the demographics here. How many students are under second year here? Just to get a notion. How many of you, or the rest are above the second year? Great. How many fifth years? And years? Okay. Yeah. All right. How many people are in the CS program? Jointly? Okay. All right. Let's get started. So let me acknowledge my collaborators. Samin Khan is the star student of this project. Do you want to stand up so people know who you are? Not too embarrassing. I mentioned Samin in particular because he's implementing all the computational and the data analysis portion of this project, which is a significant portion of it. The other collaborators are Sridhar Murthy at Rotman Institute, Rotman School of Management at U of T, and Ruth Pogita at Calgary, Haskins School of Business. I also want to mention that Samin just won this Microsoft Imagines Innovation Cup, so if you guys want to give it a go in the future, definitely, again, talk to Samin. Okay. So here's a brief outline of this talk. I'm going to introduce the basic problem of brand name gender prediction. And I'm going to introduce the approach, which is a combination of what we know about cognitive science, but also what we know about computer science. And finally, show you some initial findings that we have discovered from this kind of joint approach. I also want to talk about the courses. Again, if you have any questions, please just jump in. Okay. So, if I give you a bunch of people's names, in English at least, you would have a fairly good idea of whether they're female or male. At least in the case of English and in other languages, names tend to be gendered. Can anybody tell me what's the difference between the left-hand side and the right-hand side set of names? Yeah, go ahead.
Both the names on the left end in vowels.
Okay, that's a great observation. Anything else? Complementary to what you say, anything on the right, and it's a constant, right? So it seems intuitively, just looking at the ending part of the name is indicative of its gender. The question is how well this holds up for names more broadly. Not only in English, but also in brand names. And this is the real problem that we're trying to tackle here. Is if I give you an arbitrary brand name, say from the North America territory, can you tell us whether it's a male or a female? Right? Even though these brands might have started off genderizing their brand names to begin with, people's perception of them might be, in fact, influenced by the fact that people's names are genderized. Any guesses? What about Nike? Victory. If you know the history, yeah, that's right. So Nike is Greek ancient for female, like a female goddess. All right, so the approach we're going to take is to learn from these names a bunch of linguistic features. For example, vowel ending is one of them, but among many other features that we come up with, and to see to what extent we can predict with good accuracy gender in people's names, where ground truth is known for, and then transfer sort of that machine learning classifier, if you will, to predict brands gender. Okay, it's a very simple idea.
This is for English speakers.
This is for English.
The English-speaking world.
Yes, that's correct. And the brands we deal with are all North American brands. Most of them, I mean, even though Gucci or Italian, but most of them were North American brands. Okay. Okay. So why do you think this would work to begin with, right? There's a long tradition in linguistics / psychology of this notion of sound symbolism, is that name is informative of gender and other kinds of information. So specifically, names ending with a vowel, as one of the students just suggested, tend to be feminine. Okay? The word tend to be is especially important because this is not an absolute rule, or there's some sort of statistical tendency that names ending with a vowel tend to be feminine. Okay? But there are exceptions. Any questions so far? Okay, so we wind up collecting 17 different features. The previous slide is just a subset of these. We made up some of them, but the majority of these were directly derived from the literature. So to make it very concrete, if you have a name like Linda, we can code this name now into a set of numbers, something that the computer is especially good with, right? So does Linda end with an A? Yes. So we got a 1 here. If not, it's a 0. Okay. Some of these features are not binary. For example, how many letters are there in this name? Well, in this case, 5. Okay. 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 So armed with this kind of technique, you can then encode every single name you have, at least in English, into a string of numbers. Think of these as vectors. So when a computer reads in these names, basically just discard that part and focus on the feature part. It's a set of numbers. So that's the input to the system. But what we want to do is to really make guesses about the underlying gender. Right? And we know a lot about English name genders. And we took these from an independent database that involves 100K English names. So the goal of this machine learning approach, if you will, is to learn some sort of function, okay, that given a certain input, which is a set of features for a name, this string of numbers, the classifier has to somehow figure out what the gender is. Okay. And it turns out, just that means one there, we end up with a very simple model known as sparse logistic regression. I'm not going to go into that. Basically, it takes the weighted sum for each of these 17 features and has summed it up, okay, into some sort of decision-making process that says, hey, if the weighted sum of these features exceeds a certain number, I'm going to consider that as a female name, otherwise it's a male name. Very simple classifier. But this simple classifier actually gets us an accuracy of 80%, which says that if every 5 names, you got 4 correct in terms of gender. And where ground truth is known. And there are some differences between how well we can do in terms of female names and male names. Something that we're still trying to grapple with. Why is there such a difference? Maybe the sound of the name is really more indicative or accurately indicating whether it's female versus male. But if you have any intuitions, that is, yeah, Jeff.
Yeah, so, I don't know, one possibility I could think of is that it's often the case that traditionally, like historically, male names end up becoming female. So Leslie, for instance, used to be standard male names.
That's
still
correct.
Male, a lot of like older male names.
Yeah, that's a very interesting historical dimension. The gender of names tend to change over time. That's something that we don't fully understand, but I agree there's probably more tendency for males to neutralize and become female names as opposed to the other way around. Itself is an interesting scientific problem. Maybe that explains also why we're getting better accuracy, because for males it's just too confusing. It changes over. Okay. But the punchline is, not only we can get a classifier that predicts people's gender, we can also learn what kind of features are actually indicative or diagnostic of genders. So these bars show the weights from that little model in terms of how much they're contributing to the prediction. What you will notice is the first 4 bars, the first 4 most important features are all concerning the ending of a name. Okay, but the real thing we want to do is not just to predict people's genders. We know that's sort of a solved problem just by our intuition. The real question we want to get at is, can we learn something about gender in brand names? Certain brands might want to genderize their names to strategize their marketing strategies. And sort of the basic hypothesis here is, if there's no gender strategy at all in brand names, we would expect a 50-50 sort of percentage of male versus female names. But if that's, well, whether that's the case or not, we'll take a look. Okay, so this is a 2-dimensional visualization of about 1,000 names that we have obtained from this Cantor database called American Product. In green here are what the model has predicted as male, and in orange here is what the model has predicted as female. Okay, so this is the same model that we have used to predict gender and people's names. You see some familiar names here, such as Swarovski, Pandora, Tiffany, Nike, predicted as a female name. You also see some male gender names, such as Gerber, Deere, Ford. It's kind of making sense of the predictions here. If you look at this graph, you can almost see that the green sort of dominates and seems to suggest that the male masculinity might be preferred of a preferred strategy in brand names. So what we did next is to partition this data into different product codes. Actually, before that, we did some sanity check because there's no ground truth in terms of gender of brand names. We looked at on a couple that did have historical bases for the gender. Those marked in green are ones that the model got correctly, and the top one is actually what the model failed to predict. Okay, the model thought Amazon was a male name, but it's actually female. But if you read that into that definition more closely, you would think that the model was confused for a good reason, because it's a female warrior. So there's some level of masculinity even in that definition. So this gives us some confidence that the model is doing something sensible. The next question is, can we learn something about marketing strategy from that kind of approach? Okay, so this is a bar chart that shows percentage breakdowns of those genders in these brand names. So we're looking at 17 product categories. The red shows the percentage for female names as predicted by the model, and the green shows the percentage for male names as predicted by the model. As I said before, the basic null hypothesis is that if there's no genderizing whatsoever in the brand names, you would notice all of these percentages should lie closely to the 50% horizontal line. But that's clearly not what we see here. So first of all, if you look at names across all product categories, 60% of them are male versus 40%. Okay. So at the gross level, there seems to be a preference towards male names for some reason that we're still trying to figure out. But if you look at individual product categories, some of these are not surprising, but some of these are quite surprising. So the highlighted in green are not surprising, or these are military and man underwear brands. So it seems obvious that marketers might want to come up with clearly male sort of preferred names. But if you look at some neutral product categories like hair products, it seems surprising that male names is still preferred. Okay. Does anybody have any intuition why this is the case? Okay. Yeah.
So one thing that's even more strange, I think, is that general hair products are more male than male hair products.
Wait, which one?
So hair products highlighted in yellow
Yeah.
is more male than just the left of the
This one, right?
That's really strange.
Yeah, and if you look at this one, women underwear, you would expect sort of symmetrical strategies to apply here, but that's not the case. In fact, about 50% were actually male, or at least tend to be male names. Something that
Women
was,
are culturally invisible.
so I think part of this exercise is trying to leave open the possibility of these interesting sort of gender strategy underlying these brand names. But yeah, I do think it's worth sort of thinking about why this is the case, that this asymmetry. Yeah, go ahead.
Yeah, like they may be marketing with male gaze in mind.
Yeah, that's completely possible. And then, now we're extending this analysis to 100 product categories to see whether this asymmetry actually holds, and if so or not, why that's the case. But it's sort of a mysterious thing to us. The thing is, you can come up with all sorts of different kind of strategies, but you want to understand whether there's general principles underlying why this asymmetry exists in the first place. Go ahead.
I'm just wondering, is there a bias in the English language in general? So you would find it in marketing, but maybe the English language is just made by men, and so or it's just more male in general. I'm not sure. I don't know.
That's
No, but he's not
plausible.
pointing the other way. More names are clearly identified as females.
From the models, and
From
models.
the stats,
That's correct. So I don't know too much about in terms of the creation of English, but we do know that some brands, at least, their founders are males. And Ford, for example, is the surname of the founders, so they adopted that name. But it's an interesting question to raise here that will get us thinking a little bit. But the punchline is we did find a strong asymmetry, if you will, across 17 product categories, and this is something that we found quite intriguing, to be honest. Yeah, I'll be done in 2 minutes. So some takeaways. I hope you find that entertaining. It's not a very sort of computationally involved project, but it's certainly you can see how computation can get you potentially far with dealing with large data and learning something useful from these data. So the takeaway is that sound of the name seems to be indicative of its gender, at least if you look at the ending part in English names. I don't want to generalize it to other languages. Brand names reveal a gender asymmetry, at least in the data set that we've come across. And the final note here is to all of you guys is it seems like this is a real-world application of cognitive science, and I'll make sure that every student who come into the program have that in mind, is that cognitive science is a scientific discipline, but at the same time you can always be creative and think about ways to apply that discipline to other real-world applications. Okay, I want to spend just 1 minute on the courses. Top 403 is a 4th-year seminar course, this time taught by Professor Suzanne Stevenson, who is also from the Department of Computer Science. Suzanne is a very experienced researcher in the field of language acquisition and computational linguistics. So this year she will be teaching it by focusing on cognitive models of language. Okay. COP 260 is a new course that I will be teaching, targeting primarily second-year COP Sci students. It's titled as Data Computation in the Mind. The focus of this course will be very hands-on, so there's a lot of practical labs in it. So either if you hate Python or you like Python, you could consider at least sitting in for that course. My goal here is to ease things to make sure that everybody, even if you don't have experience with Python, well, you need to take some. 101A is the prerequisite. Mild exposure to Python is acceptable. And finally, I want to advertise for my own course. This is a graduate seminar course on computational models of semantic change, how word meanings shift over time. So some of the COP Sci undergrads, especially 4th-year undergrads last year, have taken this course and they find it pretty useful. So it's something to keep in mind. The structure of that course is seminar style, so we're expected to present research papers, and it also has a big data component to it in which you get to work with Microsoft Cloud platforms, so a bit of a stretch in all ways. So hopefully you find that useful, and if you have any questions, please feel free to reach out. Thanks so much.